Hello everyone, how are you? I hope you're fine. So today we're going to look at two-dimensional array. Okay, two-dimensional array. If you haven't watched my video on one-dimensional array, please stop watching this video and go to my YouTube profile and find one-dimensional array. Okay, two-dimensional array is representation by a matrix. Okay, previously I mentioned about one-dimensional array which can be represented by a vector. So a two-dimensional array is represented by a matrix. An integer matrix A of size m by n is declared as integer amn. So this is the name of the array amn, where m is my row and n is the column. So if I have an integer w, 2, 3, so what does 2, 3 here means? It means 2 row, 3 column. Okay, so I have 2 row, 3 column. So this is my row 1, this will be my row 2, like I can show you in this table here. Okay, so the 2 here stand for number of rows, while 3 here stand for number of column. And the total element, you multiply 3 by 3 times 2, you have 6 element. 1, 2, 3, 4, 5, 6. Two-dimensional array is important when we want to solve problems involving matrix such as multiplication, addition, subtraction, and division. To process elements of a two-dimensional array, we use two nested loop. Okay, the outer for loop is to loop through all the rows. So you have outer loop for the rows and the inner loop for the column. Okay, so if you use outer loop as I, inner loop you use J. Okay, now let's look at this matrix multiplication. So we want to look at matrix multiplication, how to write a C++ code for matrix multiplication. So you have this matrix C, A, B. A, this is my matrix A, which is 3 by 2 matrix, and matrix B, 2 by 3 matrix. And then you have matrix C, which is 3 by 3. Okay, so if I look at this matrix here, I can say more about this matrix. Okay, firstly, I need to declare my element m and n. Okay, you need to declare m and n. So I need to know what is my m, what is my n, and then there's also another one, let's call p. Okay, m and n usually refers to the size of C. So if my C is 3 by 3, so m is 3, n is 3, and p here, so we have 3, so p is my 2, p is 2. Okay, this is how what we need, some of the integers that you need to declare before you write the code. And what else we can say about these matrices? Okay, so the matrix multiplication involve an operator p here, so k from 1 to p, which is 2. Okay, which is 2, p is 2. So I, k, and you have another loop here for k. Okay, where k start from 1, 2. So k is also 2 here. I'll explain to you when you want to find this k. So you will have the outer loop for I, where I start from, let me just write it, I from 1, I less than equal than m, and I plus plus. Okay, this is for the row, and then you will have an inner loop here for my column. Okay, I need another one. This is a for loop here, for, and then you will have for j equals to 1, j less than equal than n, and j plus plus. So I will have another. Okay, so I will have, this is for my column. Okay, so usually let me emphasize here something very important. Okay, so usually your integer, your size start from 0 0. Okay, I've explained earlier on to declare an array, or to let me just show you my slide previously. Look at here. When you declare an array, if the size is 4, this is for a one-dimensional array, your initial start from 0. Initial start from 0 and then 1, 2, 3. So similarly for the for this two-dimensional array, so this is actually 0, 1, 2, and then row 1, 2. So you start from, to initialize, you start with from 0, 0. But because we don't want to do that, we want to do in terms of, I want to write it in terms of A11, A12, A13, and then this is A21, A22, A23. Okay, so if I want to write it in terms of A11, 12, instead of A00, 00, 01, and 02, so I need to have additional integer declaration earlier on, later on. Okay, I'll explain to you when we look at the coding. Okay, let's look at what type of problem we want to solve. Okay, so what is size of A? So let's say my A, okay, this is my matrix A, which is my 3 by 2, given as I have to decide what you wanna use. Maybe we can use 5, 3. Let me just find my notes. Okay, so I'll have 2 minus 3, negative 1, 4, 3, 5. Okay, and then my B, which is my 2 by 3 matrix. So my B is 3, 7, 2, 1, 5, negative 8. Okay, so by having this information now, I can write a code. Okay, let's go to your C++, Microsoft Visual Basic. So file, new project. So what do you want to call this? Say matrix mul. Matrix underscore mul stand for matrix multiplication. Or maybe I'll put 2D array, 2D array. Okay, 2D array. And then next, take empty project, finish. Okay, go to the source file, add a new item, which is my C++ code. So name as 2D array. Add. Okay, let's write. We want to find the matrix. Find the matrix multiplication. Find the multiplication. So what is my A matrix? Is 2, negative 3, 2, negative 3. Semicolon here stand for the second row. Negative 1, 4. And then I have a semicolon here. 3, 5. This is my matrix A. And then I have matrix B. 3, 7, 2. And then I have 1, 5, negative 8. Okay, this is my matrix B. So what else we need? Okay, that's it. This is our information we have. We want to find matrix C. Okay, so we have C is the multiplication of A times B. Okay, that's it. So let's start by having this header file, include iOS stream, and then we have using namespace std void main. Okay, and open curly bracket, close curly bracket. Okay, so I want to declare, I told you I want to declare, we erased it, I want to declare m and n. So I can put it here, define m. So what is the value of m just now? We said 3. Define m3 and then define, oops, put a semi, no, okay. Define n3 and then we have define p3. Okay, so these are the variables that we define. Okay, now we can start writing the code for the integer. Type my a, we have m plus 1, p plus 1. Okay, why we have plus 1 here? Remember, like I say, your initial for a start from 0, right? But we're going to have plus 1, extra 1 more, because we are starting from 1 instead of 0 in this code. Okay, and then we have b will be p plus 1 and n plus 1, and then we have c which is my m plus 1, n plus 1. Okay, so now we're gonna declare all these metrics. Remember, I'm using 1 instead of a 0 0. Are you with me? Usually it'll start from, if I look at my slide just now, I told you the table here, look at the table here. Okay, it started with column 0, row 0, -5. Okay, but I'm not writing at 0 0, I'm reading at 1 1. So that's why I have n plus 1 here. Okay, I hope you understand. So what is my element A11? 2, and then A12, which is -3, and then I have A13, no, second row will be not A13, so I have A21, which is -1, A22, which is 4, and then A31, which is 3 and 5. Okay, 3, and then A32, which is 5. Okay, so this is where we define the matrix A. Okay, so there's no semicolon here, that's why I can see I have an underline A, red underline A, because I forgot to put a semicolon here. Okay, now define the B matrix. 1 1, the first element for B11 is 3, B12 is 7, B13 is 2. Okay, and then I have B21, which is 1. I have B22, which is 5. Then I have B23, which is -8. Okay, that's all. We have A and B. Now I want to produce a statement to produce this matrix A. So I have C out matrix A. Okay, ENDL. Okay, so how to produce all this element here? We need a for loop. Okay, first for loop is for my rows. So my rows I equals to 1, and then we have I less or equal than n, I plus plus. Okay, this is for my row. Now I need to have open curly bracket and close curly bracket, and then I need to have for my column j equals to 1, j less than equal than m. Is it m? No. A, the size of A is 3, 2. So my column is 2. So instead of M, I need to put P, because P is, P should be 2. P is not 3, P is 2. Okay? Okay, resuming my, what happened here. Okay, so please take note that this is actually should be 2, not 3. So change it back to 2. Okay, now I can have my row for A from I1 and then J start from 1 to P, because I have 3 rows, 2 column. Okay, and then what we have here, J plus plus. Okay, so look at the red underline for I and J. So I need to declare an integer, int I and J. That will solve the problem. Okay, cool. So now we can now we can produce the C out. So we have C out A I J. Okay, so I have a slash T tab, and then C out ENDL. Okay, this is my matrix A. This is my matrix A. So that's end the loop here. Oops, sorry. Okay, let's end this loop here. Okay, for I equals to 1 up to J, so Aij up to P. Okay, because this P is 2. And then what will be next here? So I need to produce my matrix B. So similar to this part here, you can actually copy it or you can type it out. So I have now matrix B. Oops, that's not B. Okay, so now similar thing. So we'll have I can actually copy this whole thing here. Okay, I can actually copy this whole thing here, put it down here, but I just have to make sure they're correct. So this is for my column. This is for my column. So let's look at the size of column B. B is, you need 2 row, 3 column. So my I less than equal than P. My row is 2, and then this is M or N, doesn't matter as long they are size 3. So put an N and change it to B. Bij. Okay, so this is for the matrix A and B. Let's type it and check whether we got it correct or not. So to display the output, so let's type cin.get. Okay, let's type it now and run it. So wait. Okay, there you go. So we have matrix A and we have matrix B, which is exactly what we want. Okay, now we want to find matrix C. Matrix C. So write it C out. Matrix C. Okay. Okay, so you have defined matrix B here. Let me just put a comment here. Define matrix B, and this is to define matrix A. Okay, and now you want to define matrix C. Okay, so if you look at matrix C, the size of matrix C, if I look at here, maybe I have erased it, maybe here. Okay, so it's 3 by 3 matrix. So I need an I for my row, which use M or N, doesn't matter, and then J is also M and N. Okay, so let's go here. We have 4 I equals to 1, I less or equal than M, I plus plus. Okay, as a curly bracket and close curly bracket here. And then we have 4 J equals to 1. Okay, J less or equal than N, J plus plus. Okay, so this is for my row and this loop is for my column. Okay, so we need to be careful here because C is the matrix multiplication of I of A and B. Okay, so let's look at let me write something here. So let me write something here so that you know what I'm doing. Okay, we want to look at, oops, I want to show you something. Okay, so go to home, layout and blank layout. Okay, so we have this matrix A, which is given by 2, -3, -1, 4 and 3, 5. And then we have matrix B, which is 3, 7, 2, 1, 5, -8. Okay, so this is 3 by 2 and this is 2 by 3. So you have the matrix C, which is a 3 by 3 matrix that take the multiplication of A multiply with my B. So I want to show you what's happening here. I know you know how to multiply, but let's look at just 1 or 2 elements, okay? So you need to get a 3 by 3 matrix, 3 by 3. So how do you do? So row with column. Is it like that? Row with column. No? How do you find the matrix multiplication? How do you find the matrix multiplication of a 3 by 3 matrix? Okay, so we have this multiply with this. That will give you the first element, okay? So 2 times 3 plus, so A. So we have A11. This is my matrix A, this is my matrix B, right? So I have A11 multiply with B11 plus A21 12 multiply with B21. Okay, so this is just giving you the first element here. So I need a bigger box here. Okay, are you with me? I hope you're with me. Okay, so 2, this is my A11, A12, B11, B21. Okay, and then you will have the first element. Now to find the second element of C, you have A11 multiply with B. What is this? B12 plus A12 multiply with B22. Okay, and then the third element I have A11 multiply with B13 plus A12 multiply with B. What B is this? 21, B22, this is B23. Okay. Okay, thus you get the first row, my first row. And then to find the second row, similar process. Okay, this multiply with this, and then this multiply with this, and then this multiply with this. You will get all this value here. Okay, and then to find the last value here, this with this, 3,5 with 7,5, and 3,5 with 2,8. Okay, so you will get 3 by 3 matrix. So I hope you know the concept now. Okay, so what the problem here? The problem here is the dimension of A and B, they are not the same. See, the dimension of A and B, they are not the same. So you need to have another loop here. Okay, you need to have another loop for A for the multiplication. Okay, so I need a for loop here. Okay, this is for loop for this one, and then I need to have another for, let's call it k from 1 to k less or equal than 2. Okay, if I look at this slide here, okay, you need to have 2 here, 2. So because of my dimension for my A3, 3 by 2 and 2 by 3, so it's my P, because P is 2. Okay, and then what we have, K plus plus. Okay, now what is Cij? Cij, you have the summation, right? You have the summation, because I'm gonna find column with a row, row with column, okay, row with column. So I need to have plus here, so I need to have Cij plus here. Because I have a plus here, I need to initialize my C. What's my C? 0. This is to initial C. Okay, so this will be A. The size of A, like I say, is 3 by 2. So I can say M or N, or I mean I. My I is from up to N, right? So I can say I, A, I, K. Okay, K up to P is 2. P is 2, so up to 2 multiply B. The size of B is 2 by 3. Okay, so I can say K 3, which is my J. J is also from 1 to N. N is 3, so I can put a J here. Or I, they are the same. I and J are the same size, doesn't matter. Okay, so I need to initialize, I need to declare my K as an integer. So up here, comma K. Okay, and then what happened? You want to produce the C out for this one. So C out Cij. So I have /t. Okay, and then N here, and then C out ENDL. Let's check. I close this bracket, and then yeah, I think that's it. Okay, so this is a tricky part here. Oops. Okay, so let's check my so you know C is a 3 by 3 matrix, so you should get I from 1 to M. M is size dimension 3, and j is also up to n, which is size 3. Okay, j is also up to n. So you can get a start from 1 1 1 2 1 3 and then 2 1 2 2 and 2 3 based on this here. Okay, so it start from I1, I1 and then k will go to this loop here, 1 1, multiply with b 1 1, and then plus, I have a summation here, I is still 1, k will be 2, 1 2 2 1, j is remain 1. Okay, and then a1, that's it. A then go to, once finish this loop, once k up to 2, then it will go to the I, the second I, and so on. Okay, I hope you get the idea. Okay, let's run and check the solution if I've got it correct. There you go. Okay, so this is 3. Let's check my coding here. So I have 2 times 3, 6 minus 3, so it should be 3. And then this part here, 2 by 7 times 2, 14 minus 14 minus 15, 14. Okay, a12, what happening here, a11 plus b11, and then a12 plus b21, so 3, okay, and then this part here, a11 plus b12, so 7 times 2 is 14 minus 15, which is -1. Okay, yeah, I got it right. Okay, and then the last one, what we have, let's check another one. This is a11 times b13, so a11 is 2 times 2, 4 plus 24, 4 plus 24, 28. Okay, correct. So this is how you write the multiplication of the matrices. Okay, with the different dimension for A and B, you can get matrix C. Okay, now I want to show one more thing. What else can you find by this vector here? Okay, so if I continuing my slide. Okay, so I can also use my two-dimensional array to find the average grades. Okay, just look at this grade here. So I know my row is 2, and column is 5. Okay, this is the name of the array. My array name is grade. Okay, so the marks correspond to mathematics would be stored in the first row, whereas those corresponding to physics will be stored in the second row. Okay, so I can assume this is my mathematics. These are the marks for my physics. So you want to find the average grades. So you have a two-dimensional array because you have two subjects here. Okay, so you start from declaring my, so the matrix is look like this. Okay, so I have 80, 70, 65, 89, 90, and then I have 85, 80, 82, 87. Okay, so the size is 2 by 5. Okay, that's why we have 2 row, 5 column. Okay, so if I have a third subject, chemistry, you just have to put below here. Okay, somewhere here for my chemistry. Okay, so you have to initialize, introduce all this initial for the grade. Okay, you want to find the average grade for this I'm not sure whether they are this. I think they should be the. How can we say this? Can we say for different students or the same student, but maybe 5 attempt? Yeah, I don't know. Okay, whatever it is, but let's look at this code here. Okay, this code here, I is less than 2. Okay, I less than 2. So this is my I here. Okay, so I told you the first loop, the outer loop is for my row, and the inner loop is for the column. Okay, and why it's from 0 to 2? Because instead of starting 1 1 1 1 1 2 and so on, I'm starting with 0. Okay, I'm starting with 0. So what happened? So I have 0. I have to start I from 0. So don't forget to declare my integer I and integer j. Okay, and then when average is 0, and then I have from j from 0 till 5. Okay, less than 5, because I'm starting from 0. Okay, so if I look at here, this is my 0 1 2 3 4 0 1. Okay, so my row from 0 to 1, so less than 2. And for my column here, j, I have up to 4, so j less than 5. Okay, so you find the average. This is the sum of grades. So I have average plus will be the summation for. Since I have an average plus here, I need to initialize my average, which is average equals to 0. Okay, initialize 0, and then grades start from I 0. So I 0. So the first loop, it will be like this. It will be grades 0. When I 0, j is 0. Okay. And then within this loop, okay, I is still 0. Grades I is still 0, but my j will be 1 plus 1. So j will be 1, and then I will be still 0, and then it will add up for 0 2, and then it will add up another one for 0 3, and it will add up the last one 0 4. Okay, this is my I, this is my j from 0 to 4, which is right 0 to 4. Okay, so once it add up everything, it will find the average, which is the total division. Okay, so let's see whether I'm still recording. Okay, good. So I'm still recording here. So I just want to make sure I'm not lost. Okay, so what happened here? So it will add up all this thing and then divide by 5. So I have obtained the average for the first subject, which is mathematics, and here subject DI. So when I is 0, you have the average for mathematics, and then since up satisfied here, it's going to go to my next I, which is 1. So and then we'll go to grades 1. J is 0, and so on. Grades 1, J 1. Okay, so it will find my physics now. Okay, up to grades 1, and I is 4. So it will add up and it will get the second average for my physics course. Okay, so this is what this code is about. So you can find the average of a two-dimensional array pretty easily. Okay, so I guess that's all for a two-dimensional array. So I'll see you next week more on applications of array. Okay, so thank you. Bye for now.